This video is part of an online course of Calculus 1 and I'm gonna talk about one-side limit. Okay, what are they? If I write the limit of the function f of x as x approaches to a with a positive on top of a, it equals to L, it means that f of x approaches to L as x approaches to a from the right. What do I mean by from the right? It means that if this is x-axis, this is the point A, I'm finding the values of the function. Let me have a y-axis as well so that I can explain it better. Okay, so assume that this is my function f of x, and then x approaches to a from the right. It means that we're gonna put values that are greater than a and say what is the value of the function as x approaches to a from values that are greater than a. As you see, they're getting closer and closer to L. Okay, so this is called the limit from the right. This is called the limit from the right, or sometimes it's called right limit, as x approaches to a from the right, from the values that are greater than a. Now if I write that the limit of f of x as x approaches to a from the left is equal to L, then it means that f of x approaches to L as x approaches to a, actually I forgot, to a from the left, which means that we are approaching to a from the left hand side, and then we are gonna put the values that are less than a if we want to calculate the limit using the table. So this is called the limit from the left, or it's called the left limit. The important thing is that the limit of the function exists if the limit on the right is equal to the limit on the left, which means that we get the same value as x approaches to a from the right and x approaches to a from the left. So as a note, the limit of f of x as x approaches to a is equal to L if and only if, it means that this is the only condition that it matters, that the limit of f of x as x approaches to a from the right is equal to the limit of f of x as x approaches to a from the left. All of them should be equal to the same number. Otherwise, we don't get the limit. Okay, and we say that if they are not equal to each other, which means that we have a jump, then we say that the limit does not exist. Okay, so let's see how to evaluate the one-side limit. I'm gonna give you one example. What is the limit of f of x as x approaches to 2 when f of x is equal to this piecewise function x plus 1, as if x is less than 2, and x squared minus 4 if x is greater than or equal to 2. Okay, so to write the solution, let me graph the function first to see what's going on. So x-axis, y-axis, 1, 2. So if x is greater than 2, which means all the x's on here, we need to follow this parabola. So the parabola would be like this one. So you see it's gonna be this parabola, but we just care about the part that is greater than 2, just like that. At the point 2, I'm gonna plug in the point 2 into here because I have the equality sign in here. We're gonna plug it in there, we're gonna get 0. And when x is less than 2, we're gonna follow this line, which is x plus 1. So let me graph x plus 1. This is 1. And when x is less than 2, which means that we are here, I'm gonna follow that line. Okay, so let me make it bold. There you go. To find the limit, let's find the limit as x approaches to 2 from the right, which means that we are approaching to 2 from the values that are greater than 2. Let's put the values into the function and try to estimate the limit. So I'm gonna follow, since x is greater than 2, I'm gonna follow this parabola, x squared minus 4. Okay, so basically values that are greater than 2, I can put 2.1 and I'm getting closer to 2, and then 2.001. Okay, let's put the values. I'm gonna put 2.01 into here. I'm gonna use the calculator to find the values, and then I get 0.004001. You see, it's 0.4, it's 0.4 and then 0.04, so as you see, even based on the function, it's getting closer and closer to 0. You see, it's getting closer to 0. There you go. So this limit is 0. Now let's find the limit of f of x as x approaches to 2 from the left. So we are approaching to 2 from this side. Let's see what's going on the table. We have the table x, and then f of x. When x is less than 2, we're gonna follow this, x plus 1. Let's put the values that are less than 2 into here. So I'm gonna put 1.9 and I'm getting closer and closer to 2. 999. Okay, so I'm gonna put these values into the function. As you see, these values are getting closer and closer to 3. Okay, so the limit in here, you can also check when we are getting closer to 2, starting at this point, you're getting that. And then we are getting closer to 2, and in that case, we are getting closer to 3. So the limit would be 3. As you see, the limit from the right is 0, the limit from the left is 3, and since they are not equal to each other, so I can say that the limit of f of x as x goes to 2, this does not exist because I don't have the unique L, and this function has a jump as well. Okay, so this is all I wanted to say about the one-side limit.